All right, going from an equation to a graph. Uh, in slope-intercept form, we have the equation here, y equals 3x minus 2. Okay, our first move is just to simply label, this is my m, this is my b, right? My m, in this situation, 3x minus 2 against my coefficient, so my m equals 3. Now, as a fraction, which this is what I recommend for everybody to do, is to write it as a fraction. You got a whole number turned to fraction, you put it over 1, right? Because again, the top represents my change in y, and the bottom number represents my change in x. And that's going to be important when we're talking about our graphing, is the difference from one point to the next. So in this case, it's going to go positive 3 along our y, and then positive 1 along our x. Now the other part is our y-intercept, which in this case, our b is negative 2, okay? So I got my m set, I got my b set, we're established. Now we got to go over to actually create the graph. So our first move is to put our first point, which is at the b, which is your y-intercept, on your y-axis. Your b is always going to be on your y-axis. So I start right there at negative 2 on my y-axis, okay? Now the change from one point to the next, right? Changing y divided by changing x. Positive 3 along my y, which means, again, my y-axis is my vertical axis, the one that runs up and down. So I'm going to go up 3, and then positive 1 along my x, which means I'm going to go right 1. So from here, I would rise 1, 2, 3, and run 1. And that would be my next point, right? Which would be right here. Rise 3, run 1. And then you repeat the same pattern, right? It's a constant rate of change. From one point to the next, you're still doing the same rule. We go up 3 over 1 from that point, rise 3, run 1, rise 3, run 1, until we don't have any other spots going in that direction, okay? But again, hopefully you guys can see that we go up 3, over 1, up 3, over 1 every single time. Now, you can also go in the other direction if you do the exact opposite, right? A positive divided by positive is positive, but also if we go negative, negative, right? If we go the same direction, same signs when you divide are positive. So if we go negative and negative, and look at it this way, if I went minus 3, minus 1, minus 3, minus 1, it's the same idea. I can go down 3 and left 1, and that would give me another point along our graph. So minus 3, minus 1 would be right here. Minus 3, minus 1 would be right here. And now I have all the points that I could possibly have. Now, once again, these are linear functions. If your line went here and then for some reason you went there, all right, that is not a straight line. So that is definitely wrong. I can tell you that from the beginning without even looking at it, that I know it's going to be wrong. If it's not a straight line, it is guaranteed to be wrong when you're talking about these linear functions. But either way, you connect your dots. Maybe do a better job than that. I'll take it. Connect your dots, and there is the graph for the equation y equals 3x minus 2. And again, you can check it by plugging in any of these values, right? So if x is 2, 3 times 2 is 6 minus 2, which is 4, right? So you get the ordered pair 2, 4. Works with all of them. You work with 3. 3 times 3 is 9, minus 2 is 7, right? And we have the ordered pair here. Guess what? 3, 7, right? The ordered pair here was 2, 4. The change in y was 3 divided by the change in x of 1, right? Change in y's divided by the change in x. So all that stuff still applies. All that stuff is true. And hopefully you get a better representation of what it's actually telling you. All right, let's try another one. Let's go y equals, let's go with the negative slope here. All right, negative 2x plus 4. Okay. So my m, again, always take the operation in front of it with it, is negative 2, which as a fraction is negative 2 over 1. Change in y is going to be negative 2, and the change in x is going to be positive 1. Now, is important that it's not a negative and a negative, right? One will decrease, the other one will increase. Different signs is going to be negative whenever you're using your slope, okay? Now, the b in this situation, our y-intercept is +4, which is going to get us started on our graph here. We're going to start at +4 on our y-axis, right? Y-intercept is going to be where our line is going to cross our y-axis. So just go up. It will start at +4. Now, to get from one point to the next, right, the slope's telling us the rate of change here, which is going to go -2 and +1. It's going to go right 1, okay? So -2 along our y, +1 along our x. So we're going to go down 2 and right 1. Down 2 and right 1. All right, one of the biggest mistakes people make is they go down 2 over 2. All right, that's why I always try to have people write that as a fraction, so it kind of helps as a reminder when you're going along here. Now, you can also go the other direction, like I did earlier with the last example. If I go +2 on my y, so let's say I go up 2, I still have to go negative. I got to do the opposite with our x. So that'd be a -1. I mean, I go left 1, so I'll go +2 and left 1, up to -1, and again, those will all be points along the same line here of our equation. So yeah, it's pretty decent, not best, but there is the graph. And again, all you got to do once you have your plots pointed, you need 2 at least to get a straight line, but more the merrier. Connect the dots, and you should have a straight line that represents the graph of the equation y equals -2x + 4. All right, do one more. Let's do a fraction here. So we have the equation y equals 1/2 x + 3, okay? Our m is 1/2. Don't think anything else. Change in y is going to be +1. Change in x is going to be +2. Now, this is going to be a positive slope still, and you should be able to tell just by looking at the numbers if it's going to be a positive or negative slope, right? If it's a positive m, it's a positive slope. If it's a negative m, it's a negative slope, right? If your coefficient is positive, it's positive. Vice versa. If it's negative, it's going to be negative. So let's do it. First point is at +3 on our y-axis, right there. Now, from here, changing y is +1, changing x is +2. So +1, I go up 1, and +2, I go right 2. Okay? I go up 1 over 2. Up 1 over 2. Up 1 over 2. So, again, plot those points here. Boom, boom, boom. And we can also go opposite, so I can go -1. If I go down 1, I can also go left 2. -1, -2. That'll give me my next points. So again, it could go there, -1, -2, -1, -2, down 1, left 2, down 1, left 2. And again, it should, if you did everything correctly, form a straight line. And better than that. There we are. And there's the graph for the equation y equals 1/2 x + 3. We start at +3 right here. It's our y-intercept. And again, the rate of change is going +1 for every change in y, and then +2 for every change in x. We go rise 1, run 2, rise 1, run 2, all the way through. And there it is.